And this is the little piece that was included on the last page of worksheet 4, which if you read the front page, it does mention that the worksheet covers chapter 4 and this section of chapter 5. I overlooked that. Anyway, formula mass. The formula mass is the mass of the formula. And it can be for a molecule or for the formula unit of an ionic compound. And so it's just adding up the atomic masses of all the elements that are in the formula. So it's just like if you took, a box of mixed fruit, and you had apples and oranges and peaches and plums, and you want to know what's the mass of the fruit, but you don't have a scale, but you know how much each piece of fruit weighs. You just add them all up, right? So the formula mass is you take however many atoms of the first element there are times the atomic mass for that one. There's 2 sodiums, you've got 2 times the atomic mass of sodium. And then you add the number of the second element times its atomic mass, and you just keep going. So let's do, I think we've got an example here. So calculate the formula mass of dinitrogen monoxide, N2O. So we've got 2 nitrogens and 1 oxygen. So we're going to take 2 times the atomic mass of nitrogen. What's the average atomic mass of a nitrogen atom? 14.007. And what's the unit? AMUs. Because we're talking about individual atoms here. So that many AMUs. And how many oxygens? There's 1. So we have 1 oxygen times the atomic mass of oxygen. And we add those up. Two times 14.007 plus 15.9994. So 44.0134 atomic mass units. And if we're looking at significant figures, this involves adding. This number 2 is an exact number because there are exactly 2 nitrogen atoms. You can't have 1.95 nitrogen atoms. You've got 1, you've got 2, or you've got 3. The formula tells us it's 2. So those are exact numbers. The sig figs come in here. When I multiply this by 2, I get 28.014. That's got 3 decimal places. This has 4 decimal places. If I'm going to follow the rules of significant figures, this would have 3 decimal places. We are going to calculate a lot of formula masses and later molecular masses, which is the same process. So I'm going to give you a shortcut for sig figs on these sorts of calculations. Just go to the same decimal place as whichever one has the fewest. So, and the other thing we need to talk about is rounding atomic masses. So if you compare a bunch of different periodic tables, some of them have more digits on the atomic masses than others do. Some of them have been rounded. I, for many years, have used a periodic table where all of the atomic masses are rounded to 4 significant figures. And so what I have in my head is that nitrogen is 14.01. And oxygen is 16.00. And so what I'll be doing the rest of this session is I'm going to use the 4 sig fig atomic masses because it saves me from having to look up so many, because the only reason I know them is I just keep using them so often that I can't seem to forget them. So if I do it with those rounded numbers, I end up with 44.02 atomic mass units. So that is a little bit different than this. Is that difference significant? Is it really, really important? No. No, it isn't. So the best thing is whatever periodic table you have available, use all the digits it gives you. That's the best thing. But you can, I give you permission to use rounded atomic masses, that's what they're called. Atomic masses rounded to 4 significant figures. Do not round them off to whole numbers, okay? Some of them it'll work out okay, but for things like chlorine, where its average atomic mass is 35.45 atomic mass units, that's like almost exactly between 35 and 36. If you round that to 35, you're going to mess up your answer. Okay, so don't round them to the whole number. You can round them to 4 sig figs, that's okay, but don't round them past that. Because you round that to 35, now you're down to 2 significant figures. We're going to be using formula masses in calculations, and we don't want the calculated formula mass to limit the number of significant figures in the answer. We want the original measurement to be the limiting thing. So do we have another example? No. So any questions about that? You look at the formula and you see that, so this is combining a couple of things together. We learned earlier how to look at the formula and say there's 2 nitrogens and 1 oxygens. And we also learned how to find the average atomic mass of nitrogen. You just look on the periodic table, it's the number under nitrogen. So 2 times that plus 1 times the mass of oxygen, you add them together and you're done.